Okay, so let's talk about graphing linear functions. So if you consider the function f of x is equal to x plus 3. So if I was to let x equal to 1, and I put 1 in where I see x in the function, f of 1, where x is 1, would be 1 plus 3 is 4, and I would have generated a couple there of x equal to 1 and this other value f of 1, or f of x, or y, equal to 4. Okay? And if I let x equal 2 and slot that into the function, I get 2 plus 3 is 5. So now I have a second couple, 2 comma 5, an x and y coordinate couple. Okay? A plot of these couples will form a line, and if that's the case, a straight line, then f of x is known as a linear function. Okay? And to plot a linear function, really, only 2 points are needed, but we do a third one for accuracy. And often when we're asked to plot a linear function, sometimes we're asked or given a domain of inputs, these values here, to put in for our x values to spit out our y values, or our f of x values. Okay, so sometimes it might look like this to plot the linear function where x is between minus 2 and 3 is greater or equal to minus 2, less than equal to 3. So that means we would put values in here of minus 2, minus 1, 0, 1, 2, 3, and see what values they generate for y, to give us a list of couples or ordered pairs that we'd plot. Okay. So here's an example. Graph the function f of x equals 2x minus 4 in the domain of inputs minus 1 less than equal to x less than equal to 4. And use your graph to find what f of 3 is equal to. So if x is equal to 3, what's the y value? And the value of x for which f of x is equal to minus 2. Well, the first thing, we'll start and do this. The first thing to do is to note your x, write down your function, put your y here, your output from the function, and then gather your couples together. So we can put in just our smallest and our largest and one in between values. So we've minus 1 pops in there, 0 and 4. So we're going for our 3 for accuracy. And it generates these couples minus 1, minus 6, 0, minus 4, and 4, 4. We plot that on our graph, our x and our y, and we get this straight line graph. Okay. Now, what is f of 3? What do we mean when we say f of 3? Well, f of 3 gives us the y value when x is equal to 3. Okay, so when x is equal to 3, this is the line that we can strike through. Should be a broken line really, but anyway, x is equal to 3, and we see where this line strikes our plotted line, and we cut across to here, and we see that it's at the value of 2. Y is equal to 2. And then when f of x is equal to minus 2, that's saying what is the value of x along that line when y is minus 2. So here is our y is minus 2 line, and you can see it cuts there. And we bring that up here, and we see that's at x equals 1. Now let's talk about the intercept method, which allows us to draw a line very quickly. Okay, so if we're given an equation and it's in the form 3x minus 4y is equal to 12, it is easier to find two plotting points where the line cuts or intersects. One is at the x-axis and the other one will be at the y-axis. And a straight line graph will always cut the x-axis at y equals 0 and will always cut the y-axis when x is equal to 0. So we have our function. And so to find where it cuts the x-axis, where is that point, then we let y equal 0 into the equation here, and so that means that 3x equals 12, x is equal to 4. So our point is 4, the x, and 0, the y. Okay, that's one point on the line. And then we look for where it cuts the y-axis. So we let x equal 0, put that into the equation. So we get minus 4y equals 12, y is minus 3. So x is 0. When x is 0, y is minus 3. So 0, minus 3, 4, 0, they're the 2 points. That's the line we generate. Okay. Question 7, page 457, we're given two functions. We're given f of x equals x plus 1 as other function g of x equals 2x minus 2. And they're plotted for us in the book. So this is f of x equals x plus 1 here. This is g of x equals 2x minus 2. And you can see that just from the graph that they intersect at 3, 4. Okay? But the book asks, what is the meaning of f of x equals g of x in this situation? Well, really, it's the point of intersection of the two lines. Okay? When f of x is equal to g of x at the point of intersection. Okay? And then we're asked to solve x plus 1 equals 2x minus 2. So we're asked to just equate one function to the other, basically. This is the f of x bit here, this is the g of x, and we're just equating them to each other. So x plus 1 equals 2x minus 2. So we'll keep our x's to this side. So when we go over our x, it's 2x minus x is equal to 1 plus 2. X is equal to 3. And you can see, again, that that's the x value at which the lines intersect. Okay, so that x value here. So by equating the two functions and finding the common value of x, we could find the point of intersection of the two lines. Okay, now, how could you find the point of intersection without using graphs? Well, the answer to that would be to use simultaneous equations, where you let, now if we said it was g of x, we could have said that x maps onto, or we could just say it was y is equal to 2x minus 2. Remember from the other chapters, there's three ways to notate a function, and y equals x plus 1. So to solve these simultaneous equations, we can just change the signs and add. So change signs and add, and we get, these will cancel out, we get 0, and we get 2x minus x is x, minus 2 minus 1 is minus 3. So 0 is equal to x minus 3, x is equal to 3, which again is x is equal to 3 again. And then we can find our y value if we just put x is equal to 3 back into either of these two. It's fine, but just put it back into this one. Y is equal to 2 times 3 minus 2, y is equal to 4. So 3, 4 is our point of intersection by solving them simultaneously. Okay, and then we're asked if f of k equals g of k, what is k? K is 3. They're equal when f of 3 and they're equal when we let our input value k equal to 3 into both functions. Both functions will be equal to each other. I.e., if we say x plus 1 equals, x plus 1 equals 2x minus 2x minus 2. Well, x plus 1 is 3 plus 1, that's 4. And 2 3s are 6 minus 2 is 4. So yes, k is equal to 3, and those functions will be equal. So we looked at plotting linear equations. What about graphs of quadratic functions? Okay, so plots of quads or quadratic functions always give us this parabola curve. Okay, always this shape, parabola. And parabola is from the ancient Greek word to throw, because it kind of describes the shape of a ball if you were to throw it in flight. Okay, so the simplest quad function that's out there is y is equal to x squared, and it looks like this, where this minimum point here sits at the origin 0, 0. Note that the curve is symmetrical about the y-axis here, so it's the same here as there, there and there, there and there, there and there. And this, therefore, is known as the axis of symmetry for this graph here. Okay. There's three ways to write a function. We know this from before. We can say y equals x squared, or f of x equals x squared, or f colon x maps on to x squared. Okay, so just remember that from before. There's three ways we can notate a function. And the form of quadratic functions is in the form ax squared plus bx plus c. Okay, that's what they look like. Whereas the line, the line is f of x equals ax plus b, if you remember that from before, okay, where this a is the slope and this is the intersection of the y-axis. But let's go back to the quadratics here. So just note, if a is positive, then you get a u-shape, and if a is negative, like minus 3x squared, you'll get an n shape, inverted. So here's an example here. Draw a graph of the function f of x equals x squared minus 2x minus 3 in the domain of inputs minus 2 between minus 2 and 4. Okay, so write down your x, write down your function, and let sub x in where you see it, and you get your y values. So your x and your y gives you your ordered pairs, which you would plot to get a parabolic curve that looks something like that. Now you can use your calculator to find those points, and the way you'd do that is you'd simply hit mode 3, alpha, the bracket sign, and then the x squared sign, minus 2, 2, and that should be the bracket sign as well. Sorry, oh no, no, there's nothing there. 2, alpha, bracket, minus 3, and you hit equals, and that's putting in that function x squared minus 2x minus 3. Okay, that's what we've put in there. X squared minus 2x minus 3. And you just have to try this yourselves. And you'll be asked for a start. So you type in minus 2 equals. That's the domain, the beginning of the domain. And end 4 equals. And step is it's suggesting 1. You just hit equals. That's okay. And your ordered couples should appear for you on the screen. So just try that yourselves. Okay. Quick way of generating the correct plots, the correct couples. Okay, so what about using quadratic graphs then? Let's have a look at reading and looking at quadratic graphs. So what does, when we're asked to solve the equation f of x equals 0, we're given a graph and we're asked to find f of x equals 0. What are they saying there really? What they're saying to you is, that's the solution of the equation when it's equal to 0. That's the values of x that will give us a y value of 0. Do you remember we said f of x equals y equals f colon x maps to? Okay, but this is f of x equals 0. Our 0 is here. What's that value of x when plugged in here to give us 0 there? Okay, so the solution gives us the x values of the points, so that's what it's saying, but as well as that, what we're actually getting is the x values of the points where the curve cuts the x-axis. So if we find these values of x that give us 0 here, if we could do it by the factors, which we'll look at here in a second, but basically we can just, to find f of x equals 0, we look at our curve, see where it hits the x-axis, and that's our answer there. They are x values, or they're known as our roots, or our zeros, okay? When the y is 0, there are zeros or roots, okay? There's your zeros there. Okay? Now, we could do it mathematically the other way, not graphically, and we could say, okay, here's our function. Let's find the factors of the function, so that's x minus 3 and x plus 2. So x minus 3 equals 0 because x minus 3 times x plus 2 is equal to 0. So x minus 3 equals 0, so x is equal to 3. Or x plus 2 equals 0, so x is equal to minus 2. So they are actually the points where the curve cuts the x-axis. So actually that's 3 and that's minus 2 on the x. What about if we're solving the equation f of x equals k, where k is any real number? Okay, so let's say we're given an equation, a function, f of x equals x squared minus 3x. And we're asked to find f of x equals 2. So f of x equals k. So in this case, our k is 2. Okay, so we're asked to find, what's the value of x that gives us 2 as the output, not 0. Okay, not 0 now. Before we were looking at f of x equals 0. Now we're looking at f of x equals 2. Okay, so before we noted that when f of x equals 0, we just looked at where the graph cut when y was 0. Okay, y was 0, y was 0, y was 0. Now we need to look where y is 2. So we go 1, 2, and we draw the line y is 2, and we note where on the x-axis that line cuts that graph. And in this case, it's at x equals minus 0.6 and x equals 3.6. If we were asked to solve f of x equals minus 1, then we'd go down to minus 1 and we'd go here, we'd see where it cut the graph, and we'd find that value of x, and here we'd find that value of x as well. When is a function negative? Okay, well, it's negative when the curve is below the x-axis. So you can see that here this function is negative for values of x from minus 2, x greater than minus 2, going that way, to x less than 4. Not less than or equal to now, less than 4. But for any values that you put into the function, they'll be underneath the x-axis. The y value will be negative, and therefore the y value will be negative for values minus 2, minus 1, 0, 1, 2, 3, up to 3.999, not quite 4, okay? And then when is it positive? Well, it's positive if you put x into the given function, a value of x x is less than minus 2. So if you put minus 2.1, 2.2, 2.3, 2.4, 2.5, you'll get positive, or greater than 4. So 4.1, 2, 3, 4, 5, 6, you'll get a positive y value, okay? Positive y's and negative y's.